Good morning. Happy Tuesday. All right, let's see. Sending audio, streaming is happening, preview is working. All right, looks like we're up. All right, so let's see what the current plan is today. Where are we? Move that over here. Okay, so in the Learning Rust, let's cat the README. Okay, so we're currently at chapter 7.1, Rules of Module File Systems. Right, because we are working on the mod and the ability to use like multiple files, sort of pull things in, create libraries. Oh, the preview window froze. Let's make sure that no drop frames. So I'm guessing just the preview window froze, and that's all that it really is. So hopefully I'm still streaming. Everything is good. I'm gonna continue on as if I am, because at least I'm recording it. Okay, so chapter 7.1. Let's actually CD into chapter 7. Right, because we have this communicator here. And this is what we're building up right now. And we have this entire multiple folder system here because in lib.rs, we're just sort of saying bring in mod network, bring in mod client. We have tests here, which are pretty awesome to have. And we can say mod network, bring in network, which then we have just a mod rs. That's how it knows, like, okay, this is the basic file in here. And if we didn't have a mod rs inside of network and like another network.rs, it would get really confused because it wouldn't know folder or otherwise. And of course the client doesn't need a folder because it's just its own thing. All right, so let's go and grab the actual book. Rest. All right, the second edition, and we're looking for chapter 7.1, mod in the file system. You know, did I actually write down? I don't think I wrote down what subsection I was at. I think that's... because like we did all of this stuff. And I think we sort of like we're flying through this area. I don't know if we actually truly covered it. I'm trying to remember to yesterday morning. Okay, so we had this error. We had to change, create these folders. Now when we run, everything will work. Okay, so the folders. I think we got through this. So we have the 3 modules. Okay, so I'm gonna say we're at the rules of module file systems. Let's summarize the rules of modules with regard to files. If a module named foo has no submodules, you should put the declarations for foo in a file named foo.rs, which is what we have with client. If a module named foo does have submodules, you should put the declarations for foo in a file named foo/mod.rs. These rules apply recursively, so if a module named foo has a submodule named bar and bar does not have submodules, you should have the following files in your source directory. Right. The module should be declared in their parent module's file using the mod keyword. Next, we'll talk about the pub keyword and get rid of those warnings. What warnings are we actually getting right now? Let's try it. Cargo build. No warnings. No warnings at all. So I wonder if that's another part of the book that's changed since then. But anyways, let's move on to chapter 7.2. Controlling visibility with pub. We resolved the error messages shown in listing 7.5 by moving the network and network server code into the source network mod rs and source network server rs files, respectively. At that point, Cargo Build was able to build a project, but we still get warning messages about the client connect, network connect, and network server connect functions not being used. Really? So mod network, mod client, and in mod rs, function connect, I mean, we have these here. They're definitely not being used, and we have these errors. But in communicator, we're not getting that in the actual, like in cargo build here. Okay. That's strange. I did not expect this to work. I didn't change directories or anything. I just resaved the file, but it should have been saved there already. I don't know. I don't know how to explain that. I'm going to ignore it. Now we're getting those errors. So why are we receiving these warnings? After all, we're building a library with functions that are intended to be used by our users, not necessarily by us within our own project. So it shouldn't matter that these connect functions go unused. The point of creating them is that they will be used by another project, not our own. To understand why this program invokes these warnings, let's try using the connect library from another project, calling it externally. To do that, we'll create a binary crate in the same directory as our library crate by making a source main rs file containing this code. So in source main rs, so let's take a look at what that is. So in source, we have a lib rs. So in here, we'll also be able to create a main.rs. And that's right next to lib, yes. So we're going to want to have external crate communicator and then communicator client connect. So extern crate, did it say? Yeah. Create communicator function main and then communicator client connect, right. So communicator client connect. So if I save this, surprised didn't get any red or anything. We do another cargo build and expected one of, so now we get a completely different error. That's because I forgot to put a semicolon on here. Save that. Module client is private, so we have to publish it, and that's I think what they're about to get to. Otherwise, it's only an internal one for the library. We use the extern crate command to bring the communicator library crate into scope. Our package now contains two crates. Cargo treats source main rs as the root file of a binary crate, which is separate from the existing library crate whose root file is source lib rs. This pattern is quite common for executable projects. Most functionality is in a library crate, and the binary crate uses that library crate. As a result, other programs can also use the library crate, and it's a nice separation of concerns. Good morning, Avarice. Welcome to the stream. From the point of view of a crate outside the communicator library looking in, all the modules we've been creating are within a module that has the same name as the crate, communicator. we call the top level module of a crate the root module. So that would be the lib.rs and the main rs. Also note that even if we're using an external crate within a submodule of a project, the extern crate should go on our root module, so in source main rs or in source lib rs. Then in our submodules, we can refer to items from external crates as if the items are top level modules. So basically that means that they're global, like they're in a global scope. Right now, our binary crate just calls our library's connect function from the client module. However, invoking cargo build will now give us an error after the warnings. Module client is private. Yes. Aha. This error tells us that the client module is private, which is the crux of the warnings. It's also the first time we've run into the concept of public and private in the context of Rust. The default state of all code in Rust is private. No one else is allowed to use the code. If you don't use a private function within your program, because your program is the only code allowed to use that function, Rust will warn you that the function has gone unused. After we specify that a function like client connect is public, not only will our call to that function from our binary crate be allowed, but the warning that the function is unused will go away. Marking a function as public will lets Rust know that the function will be used by code outside of our program. Rust considers the theoretical external usage that's now possible as the function being used. Thus, when a function is marked public, Rust will not require that it be used in our program, and will stop warning that the function is unused. Okay, so I feel like that repeated itself once or twice. But all right, so we're using communicator client connect. And I almost feel like we could do this, right? Or is that use? I guess like it's different from external crate, because I've also seen like the use communicator client. Can I do that so that way now I just have client connect? I don't see. Okay, so that's perfect. And then the other thing that we want to do is, all right, so this is client. So in librs we have client. So we come in here and connect. And if we pub, so to make it public, function is never used. Is there actually a public? No, that does not look right. I'm guessing that. I know it's going to tell me in the very next section and like actually show me the code. I just want to see if it's if it makes sense like this. Cargo build. Okay, so function is never used, connect, function is never used, function is never used. Module client is private. Oh, so the entire module client is private. So I would potentially have to publish that, but is it also telling me that I have to publish this? So come on, right there, pub mod client. Now in client, now its function connect is private. So now I publish this. And then those errors go away and we just get the function is not used. So it sounds like these are, Rust like forces us to be extremely explicit with what is private and what is not only with the functions themselves, but the modules are going to be used by something else. So that's interesting. Let's go back and actually read what they tell us about it. Making a function public. To tell Rust to make a function public, we add the pub keyword to the start of the declaration. We'll focus on fixing the warning that indicates client connect has gone unused for now, as well as the module client is private, error from a binary crate. Modify source librs to make the client module public, like so. So pub mod client. The pub keyword is placed right before the mod. Let's try building again. But now it's the... So I didn't actually read the error message properly. It was telling me that the module was private, and I was just thinking, oh, it must be the function is private. Hooray, we have a different error. Yes, different error messages are a cause for celebration. The new error shows function connect is private. So let's edit source client rs to make client connect public too. Okay, so yep, pub function connect. Now run cargo build again, and we have what we have, just the errors about not being used. The code compiled and the warning about client connect not being used is gone. Unused code warnings don't always indicate that an item in your code needs to be made public. If you didn't want these functions to be part of your public API, unused code warnings could be alerting you to code that you no longer need that you can safely delete. They could also be alerting you to a bug if you had just accidentally removed all places within your library where this function is called. But in this case, we do want the other two functions to be part of our crate's public API. So let's mark them as pub as well to get rid of the remaining warnings. Okay, so we're going to make sure that everything is public now. So in librs, network is a public module, and which means that the connect is public here, and also this module server is public, which means that in server, this connect is also public. All right, so we should have no errors anymore. So if I cargo build, everything perfect. Oh, I think we did a little bit too much. We're still getting an unused function warning. Not me, but that's because I think they just put it on the module, not the function. Even though network connect is set to pub, the reason is that the function is public within the module, but the network module that the function resides in is not public. We're working from the interior of the library out this time, whereas with client connect, we worked from the outside in. We need to change source librs to make network public too, like so. All right. Yep, I fixed all that stuff. Privacy rules. Overall, these are the rules for the item visibility. 1. If an item is public, it can be accessed through any of its parent modules. Okay. 2. If an item is private, it can be accessed only through its immediate parent modules and any of the parent's child modules. Okay. Privacy examples. Let's look at a few more privacy examples to get some practice. Create a new library project and enter the code enlisting 7.6 into your new project, source librs. Okay, so this is just like an example. So let's come into here, and we're going to do cargo new -- lib, and we're going to call this an example library. So we'll go into example and create a library, and we're going to enter in this code. So I'm going to put this over to the right, put this over to the left, and cd into source. Let's just vim the lib.rs. Okay, so we're going to have a module outermost. So mod outermost. Oh, do I not have syntax highlighting on this? Oh, right, it doesn't know what Rust is, so never mind. I'm not gonna do this. Come out one. Let's open up code here. Later, source lib. Okay, so here's our mod outermost. And so inside we're going to publish, but because the outermost mod is not published, it should tell us that it can't do this. So pub function middle function that does nothing. And then we have a private, so this is just function middle secret function. And then mod inside, so this is going to be a module inside outermost. So we have then a public function inner function, and then a inner secret function. So function secret function. Okay, so then we have a function out here that's going to be called try me. Okay, so function try me, we're gonna be attempting to call these functions. So we will have so the outermost, then inside of there we have the middle function, and we attempt to call it. Then we have the outermost middle secret. So we're just going to attempt to call all of these and see which ones we can and cannot. And it looks to me like we should not be able to use the secret one, but the published ones we can. But because we didn't publish the module, is that a problem? Or is that only if it's like a crate that's pulling in? So questions to be answered. I also feel like to make this a little bit easier, we can use outermost. So that was a really interesting, was that, I can't remember whose code that was. Was that yours, Averis, where you showed I can use this as a pattern? Unused import outermost, right. So now I can just say middle function like that. Yep, and so now I can use middle secret function, inner function, and secret function. Save all of these. Cannot, oh, right, because this would be inside. Failed to resolve. Use of undeclared type or module inside, but inside is off of outermost unless it's because it's not public. I think it was me, yeah. Yeah, that's actually super interesting to do. Like this reminds me of just like the general imports that you get in C. Except you just have to be explicit about, I'm gonna bring everything in, I don't care. One thing I'm curious about, does it do tree shaking with this? So if I only use one of the functions, but I brought in them all like this, when compiled, will it still be as if I only brought in a one function because it optimizes for that and just drops the rest of the code? Okay, so are you upset because you are not public? Cannot find middle secret function. Oh, interesting. Right. That's middle secret function was in here. Then we have inner function, which was inside, and inside secret function. And so if I put this back, we're going to get errors because it can't see inside. Middle secret function is also secret. So we're getting these errors because only 2 of these are public, but the inner function cannot be called because inside itself is not public. Usually glob imports are considered bad style, I think, but for some cases they come in handy. I can imagine that. So if I wanted to pull these all in, I guess it would be best to just pull in outermost like this. And then if I pull in outermost, I guess like this doesn't really do anything, does it? Because I would still need to do that. It would be like outermost inside. So then I can do inside like this, and these 2 would want the outermost like that. But I could also imagine that it's just best practice to, in this case, do something like this and just show off what we're really doing. So outermost middle function we can call, outermost middle secret function we cannot because it's private. Outermost inside inner function we can't because the module is private. Yeah, so that's our problems. Before you try to compile this code, let's take a guess about which lines in a try me function will have errors. Unfortunately, we already see this. I think the unused code gets optimized out. You can also specify specific items to import like this. Use outermost, middle, oh, so like destructuring right in there. Is that, those are curly brackets. So I could do this. Use outermost, colon, colon, curly brackets, middle function, middle secret function. Let's just do middle function and then inside. Now, can I do this? Inner function. I know this will look terrible, but I'm just curious if this will work. So outermost, then middle function, I should be able to go like this now. Save that. And that still works. Then outermost middle secret function is still full like this. And it's telling it found it, it's just private. And then we have inner function, which is going to be like this. And it's interesting that it's not giving me the error here, it gives me the error here. Outermost inside secret function, did I? Yeah, so that is a way for me to like delve way, way down. I don't believe that I have any kind of unstable, I think this is stable. So it may already be here. Either that or the syntax is here and it's not actually letting me do this. It's just that code is figuring it out for me. But anyways, it's yelling at me for the appropriate things. Looking at the errors, the try me function is in the root module of our project. The module named outermost is private, but the second privacy rule states that the try me function is allowed to access the outermost module because outermost is the current root module, as is try me. Oh, so we don't have to publish this one. The call to outermost middle function will work because middle function is public and try me is accessing middle function through its parent module outermost. We determined in a previous paragraph that this module is accessible. The call to outermost middle secret function will cause a compilation error. The middle secret function is private. So right here. So the second rule applies. The root module is neither the current module of middle secret function, outermost is, nor is it a child module of the current module of middle secret function, which inside is. The module named inside is private and has no child modules, so it can only be accessed by its current module, outermost. That means the try me function is not allowed to call outermost inside function, or outermost inside secret function, which is what we see here. And I think I'm blocking this, so I'm gonna full screen again. Fixing the errors. Here's some suggestions for changing the code in an attempt to fix the errors. Before you try each one, make a guess as to whether it will fix the errors, and then compile the code to see whether or not you're right, using the privacy rules to understand why. What if the inside module was public? So if we take inside module and make it public, that will cause the inner function to work. So this error would go away. So let's try it. And yep, that fixes that. What if outermost was public and inside was private? So if I remove this and then make this public, it won't change anything, because what we just read about is that this is public by default, regardless of whether or not I want it to be. So yeah, it doesn't change anything. Now, can I force this to be private? Is there a private? It turns red. Does it really not like that? Yeah. So I can't like force privacy and say, no, even though you're default public, I don't want you to be. What if in the body of inner function, you called outermost, so in the body of inner function, you called outermost middle secret function? The two colons at the beginning mean we want to refer to the module starting from the root module. Okay, I was wondering about that. So inside of inside here, in the body of inner function, so in here, we're going to call middle secret function. That should work because this is a secret available to the library. Since this is a child, it should have access to the scope and therefore the privacy of whatever it's inside. So let's try it. So this brings us to outermost, and I guess, does it bring us outside of outermost? Because it's saying we would need that outermost. So outermost, then we can do middle secret function. Oh, interesting, it doesn't have it, so I'm guessing that means that it won't work. Middle secret function, we just call that. Save it. Nope, it totally does. It just was code being a little bit weird for it, like, and not even showing me that it was an option to write. Feel free to design more experiments and try them out. All right, well, I think this is sort of good to keep in mind for this. Next, let's talk about bringing items into scope with the use keyword. So chapter 7.3. Referring to names in different modules. We've covered how to call functions defined within a module using the module name as part of the call, as in the call to tested modules function shown here in listing 7.7. So a public module A, which we learned we don't need to make this public, but I guess we can to make sure that it everybody understands looking at it that it is. Public module series, which is a child, public module of, which is a child of series, public function nested modules, and then main, a series of nested modules. Haha. As you can see, referring to the fully qualified name can get quite lengthy. Fortunately, Rust has a keyword to make these calls more concise, which is that use. Bringing names into scope with the use keyword. Rust's use keyword shortens lengthy function calls by bringing the modules of the function you want to call into scope. Here's an example of bringing the A series of module into a binary creates root scope. So use A series of, which means now we can use of nested modules. The line use A series of means that rather than using the full A series of path, wherever we want to refer to the of module, we can use of. The use keyword brings only what we specified into scope. It does not bring children of modules into scope. That's why we still have to use of nested modules when we want to call the nested modules function. We could have chosen to bring the function into scope by instead specifying the function in the use as follows. So public module, so this is the same thing, use a series of nested modules, and we can just use nested modules. Doing so allows us to exclude all the modules and reference the function directly. Because enums also form a sort of namespace like modules, we could bring an enums variance into scope with use as well. For any kind of use statement, if you're bringing multiple items from one namespace into scope, you can list them using curly brackets and commas in the last position, like so. So this is what you were saying, Averis. So enum traffic light, use traffic light red and yellow. So main let red equals red, let yellow equals yellow. So it's essentially creating like a subtype, almost like grabbing just that and saying, well, it's still going to be traffic light, but now we don't have to do traffic light red. I'm not sure I really like that, because like for the functions I can understand that. For enums, I don't know. I feel like this can get really confusing because they're custom types essentially. And I know that there's the capitalized first letter, which tells us what's going on a little bit more. I guess I have to think about it. All right, we're still specifying the traffic light namespace for the green variant because we didn't include green in the use statement. Bringing all names into scope with a glob. To bring all the items in the namespace into scope at once, we can use the star syntax, which is called the glob operator. This example brings all the variants of an enum into scope without having to list each specifically. So here we can just do traffic light star, so we can use them all. The asterisk or star will bring into scope all the visible items in the traffic light namespace. You should use globs sparingly. They are convenient, but this might also pull in more items than you expected and cause name conflicts. Using super to access a parent module. So I'm used to super being in an object-oriented language, so that you can essentially, well, in a case of like JavaScript, connect the prototypes together, or in a classical language, basically extend and get all of its methods and properties. As we saw in the beginning of this chapter, when you create a library crate, Cargo makes a test module for you. Let's go into more detail about that now. In your communicator project, open source librs. All right, so let's go back into here. I believe we're done with this. I'm going to close this window. And here we go. So librs. Mod test, it works, assert equal 2 plus 2 is 4. So totally normal to most testing frameworks and libraries that I've seen. Chapter 11 explains more about testing, but parts of this example should make sense now. We have a module named tests that lives next to our other modules and contains one function named itWorks. Even though there are special annotations, the test module is just another module. So our module hierarchy actually looks like this. So we have the communicator, the client, the network, the client that's part of network, and the tests. Tests are for exercising the code within our library. So let's try to call our client connect function from this itWorks function, even though we won't be checking any functionality right now. This won't work yet. So client connect. So we want client connect, so itWorks asserts equal, I guess we're removing the assert. So we're just gonna call client connect like that. Now they're saying it won't work, but I'm not getting an error. So I want to actually try this with the cargo test. Oh wait, I'm in the wrong one. Communicator cargo test. Use of undeclared type or module client. Now, do I have to put the ... in front of it? I know it's telling me. It's going to tell, the book's going to tell me. Aha, I do. So I need to go like all the way up to the top, and then I can start doing these. All right. So we get this error. The compilation failed, but why? We don't need to place communicator : in front of the function like we did in source main rs, because we are definitely within the communicator library crate here. The reason is that the paths are always relative to the current module, which here is tests. The only exception is in a use statement where paths are relative to the crate root by default. Our test module needs the client module in its scope. So how did we go back up one module in the module hierarchy to call the client connect function in the test module? In the test module, we can either use leading colons to let Rust know that we want to start from the root and list a whole path like this. So that's the : client connect, that's what we did. Or we can use super to move up one module in the hierarchy from our current module like this. Super : client connect. Interesting. So that only moves up one. So if I create a mod within a mod, I would need to potentially do super to like go up 2. So this should also work. Yep, yeah, it works as well. These two options don't look that different in this example, but if you're deeper in a module hierarchy, starting from the root every time would make your code lengthy. In those cases, using super to get from the current module to sibling modules is a good shortcut. Plus, if you've specified the path from the root in many places in your code, and then you rearrange your modules by moving a subtree to another place, you'd end up needing to update the path in several places, which would be tedious. It would also be annoying to have to type super : in each test, but you've already seen the tool for that solution, use. The super : functionality changes the path you give to use so it is relative to the parent module instead of to the root module. For these reasons, the test module, especially use super something, is usually the best solution. So now our test looks like, okay, so in our tests, so they're suggesting that we do it up here and say use super client, and now we can just do connect, or client connect. All right, still working. When we run cargo test again, the test will pass, and the first part of the test result output will be the following. So, yep, it works. Summary. Now you know some new techniques for organizing your code. Use these techniques to group related functionality together, keep files from becoming too long, and present a tidy public API to your library users. Next, we'll look at some collection data structures in the standard library that you can use in your nice, neat code. All right, so what would be next? Chapter 8. So that felt like a more of a sort of a quick chapter where we're just talking about how to pull things out into different parts. Common collections. Rust Standard Library includes a number of very useful data structures called collections. Most other data types represent one specific value, but collections can contain multiple values. Unlike the built-in array and tuple types, the data these collections point to is stored on the heap, which means the amount of data does not need to be known at compile time and can grow or shrink as the program runs. Each kind of collection has different capabilities and costs, and choosing an appropriate one for your current situation is a skill you will develop over time. In this chapter, we'll discuss 3 collections that are used very often in Rust programs. A vector allows us to store a variable number of values next to each other. A string is a collection of characters. We've discussed the string type previously, but in this chapter we'll talk about it in depth. A hash map allows us to associate a value with a particular key. It's a particular implementation of the more general data structure called a map. Okay, so vector allows us to store a variable of numbers next to each other. So that's what I understand of vectors from like making games, which is really just like X, Y, and Z. So for example, for a 3D vector. A string is a collection of characters. So we've already, okay, so a string is a common collection that's stored on the heap. And so these other two are also like strings stored on the heap. And a hash map, that, I wonder if that's going to be closer to what I think of as an object in JavaScript or a table in Lua. To learn about the other kinds of collections provided by Standard Library, see the documentation. We'll discuss how to create and update vectors, strings, and hash maps, as well as what makes each special. All right, I'm not going to worry about the documentation right now. Let's sort of worry about these, and then I'll dive into this later. Okay, vectors store lists of values. The first collection type we'll look at is vec type, also known as a vector. Vector allows us to store more than one value in a single data structure that puts all the values next to each other in memory. Vectors can only store values of the same type. They are useful in situations in which you have a list of items, such as the lines of text in a file or the prices of items in a shopping cart. Creating a new vector. To create a new empty vector, we can call the vec_new function as shown in listing 8.1. Okay, so we don't need to like bring it in off the standard library. It's just available to us. Or I think, didn't somebody tell me that like it will auto use essentially for some, like for the standard library ones? Okay, so we're going to create a new vector. Let's go ahead and close this out. We're in communicator. We want to take chapter 8 and cargo new. I don't need the dash dash bind because that's the default, and this is going to be vectors. Or rather, I'm just going to call this, I'll just call this vectors. cd into vectors and code dot. Okay, so inside of here, we want to create a new vector. Okay, so creating a new vector, we're going to let v, so the name of our variable v, and its type is vec I32. So it's a signed 32-bit integer, and we're assigning it to vec new. So of course it's not being used, but I kind of wonder, so we have that. Can I say let other v not give it that turbo was it the turbofish syntax, and just say vec new like that? Type annotations needed. So what if I give it a type of, like, just say 55? 5.3. Okay, so it needs the turbofish syntax in order to make it right. So this doesn't work. It needs the type annotations. All right. Note that we added a type annotation here. Because we aren't inserting any values into this vector, Rust doesn't know what kind of elements we intend to store. This is an important point. Vectors are implemented using generics. We'll cover how to use generics with our own types in Chapter 10. For now, know that vector t, type provided by the standard library, can hold any type. And when a specific vector holds a specific type, the type is specified within angle brackets. In listing 8.1, we've told Rust that the vector t in v will hold elements of the signed 32-bit integer type. In more realistic code, Rust can often infer the type of value we want to store once we insert values. So you rarely need to do this type of annotation. It's more common to create a vector t that has initial values, and Rust provides the vec macro for convenience. The macro will create a new vector that holds the values we give it. Listing 8-2 creates a new vec I32 that holds the values 1, 2, and 3. Oh, so I need to use, okay, and it sort of like has square bracket syntax. So then we could say let auto v equals vec the macro, and we pass 1, 2, and 3. Now, is it guessing? Because we've given initial I32 values, Rust can infer the type of v is vec I32, and the type annotation isn't necessary. Next, we'll look at how to modify a vector. Now, but is that really true? Because 1, 2, and 3 could be I32, but it could also be U32. Unless I do something like -3, which would definitely make sure that it knows that it's an I32. Or like 33.3. Now it knows it has to be a float. Wait, we'll not do that. Mismatch types. Expected integral variable found floating point variable. Expected type integer. Ooh, what if I do like 0 in all of these? Right, so now then it works, but because each separate one has to obviously be part of the same thing. Rust defaults to I32 if there are not any other constraints. Oh, okay, so that explains things. So it sees this first one, and I think for floats the standard is float 64. Yeah, I don't remember it mentioning what the standard was, but it probably did it in the table, and I forget. So if I have like 1.0 to make this float, and I give it the rest are not, will it not be happy because these are I32s essentially? Interesting. Expected floating point variable found integral variable, but it's not yelling at this one. So if I give this a 2.0, then, so it's finding the first error and not moving on. That's interesting to know. Also, why is this not yelling at me anymore? That is super interesting that it's sort of only giving me one error. But I don't really know what to think about that. I'm going to comment out this code lest it cause problems with other things. I'm also going to take this, cut that, put that right above here. Okay, so I'm gonna save you, take you away. Let's go ahead and also update where we are. So we're in Learning Rust. We're gonna vim the README. So we're currently at chapter 8. What is this? 8.1? 8.1. We've just finished creating a new vector, so we're now going to be at updating a vector. Okay, so that's all pretty awesome. I'm going to quit this and get this all added in there. Get add dot, get status. Everything looks good here. Get commit -m, finished chapter 7 and moving on to chapter 8. And push that on up. So I have all these code examples on GitHub. The link to the repo is in the description for this video. So yesterday, in yesterday's video, I talked about how I put a poll on Twitter about like where to potentially do these streams if we want to continue on YouTube, or if we wanted to switch over and try Twitch out. And being extremely helpful, I had exactly completely tied vote. I had 2 votes for YouTube, 2 votes for Twitch. So what I think I'm going to do is finish out the week here on YouTube, and then switch next week, try out Twitch, and I'll create a video maybe like on Friday or this weekend saying like where that's going to be. It's going to be the same time. I'll also be archiving those videos onto YouTube, so we won't have to worry about that. And then about like not being able to see them on YouTube. And we'll just see how that is. So with that being said, I think we're done with this morning's stream. We've got through a full chapter and moving on to other data types, which is fun and exciting. So thank you, Averis, for stopping by. Thank you, everybody, for watching, for either lurking or watching the VODs later on. If this is helpful, please leave a comment. Let me know if you're going through this learning as well, or just how you like it. And if you do like it, please subscribe to the channel, and we'll make sure that we keep on getting some content like this for you. And with that being said, thanks for watching, and I'll see you next time.